Okay, in this example, it says, use a graph of f of x equals to 2x minus 1 over 3x plus 2 to describe its end behavior. And I have to support it with the conjecture numerically. Well, first of all, let me get my asymptotes. Because this is a rational function, I can expect asymptotes. So based on the two rules that I give you, the simplification, the summary that I give you on vertical asymptotes and horizontal asymptotes, we're going to go ahead and follow that, okay? So number one, you look at the denominator, and the denominator, it's 3x plus 2. So I'm going to let 3x plus 2 equal to 0. I find the x, I solve for x. So here I can find my vertical asymptote at negative 2/3. Okay, so that is the vertical asymptote at negative 2/3. So over here in my graph, I can go to here's negative 1, negative 2, negative 3, 1, 2, 3. 1, 2, 3, 1, 2, and 3. So first, I need to plot that asymptote at negative 2/3, which is 2 of 3 parts on the negative side. So it's about right here. There's my asymptote. Vertical asymptote, which means up and down. Okay, so here's negative 2/3. Now, let me analyze the graph from the horizontal perspective, horizontal asymptotes. Notice that the slope is 1, this is 1, so therefore this is going to be my horizontal asymptote, A over B. So this is vertical asymptotes, horizontal asymptote at y equals A over B. The A is 2, the B is 3. So 2/3, it's 2/3 of 1, so 2 out of 3 parts, so it's about right here, 2/3, and that's going to be my horizontal asymptote. So I draw a line, dotted line, because it's an asymptote. Every time you have asymptotes, it's dotted lines, okay? So there I have my 2 asymptotes. Now I can find points at x is equals to 1. Let me first try the 0, okay? At x is equal to 0, these 2 elements disappear, so that's going to be negative 1/2. So I'm just looking for points, negative 1/2. So my graph is going to be passing through negative 1/2. Let me use the blue marker instead. So negative 1/2, right there. And then at x is equal to, as I let the function equal to 0 to find my y-intercept, the x-intercept, let me put here, x-intercept, as you remember, you let the y be equal to 0, okay? So for y-intercept, you let the x be equal to 0. So when I found the first one, which was the y-intercept, I let f of x equal to 0, so it was 2 times 0 minus 1, and 3 times 0 plus 2, which is negative 1/2. So that's how I find out the y-intercept. Now let me go ahead and find my x-intercept. I let the y be equal to 0. So 0, it's f of x, and this is 2x minus 1 over 3x plus 2. Then I can just cross multiply, put a 1 under the 0. So it would be 0 equals 2x minus 1. And then I just find the x value, solve for x, so that is 1 equals 2x divided by 2, x is equals to 1/2. So at x equals to 1/2, which means that at x is equal to 1/2, y is going to be 0. Okay, so that's the point. 1/2, comma, y is 0, and for the second one was 0, comma, negative 1/2. So with this, I'm finding my y-intercept and my x-intercept, which means that my graph is going to be coming like this. Okay, and if I want to find a point on the left side, just to have an idea of what's going on the left side, well, let me try something like negative 1. See, notice that Negative 1 is on the left side of that asymptote. So let me try that negative 1, put it into the function just to find a point over here, and that way I know if it's up here or if it's down here, okay? So I'm going to find the value at x is equals to negative 1. So f of negative 1 equals 2 times negative 1 minus 1 over 3 times negative 1 plus 2. I simplify that, negative 2 and then minus 1, negative 3 and then plus 2. Simplify, that's negative 3 over negative 1, which is a positive 3. So at x is equals to negative 1, y is 3. So I plot that point, negative 1, 3. So somewhere up here, and then I can just continue the graph going like that. Okay, so you can get more points if you want to, and you'll find out that the graph is up there. Okay, now what? Let me conclude. What is the conclusion? Okay, the conclusion, which is the end behavior. See, I did all of this to get the graph so that I can know what's going to be the end behavior. So the end behavior, the answer to this problem is going to be the limit of the function of x at x approaches to positive infinitive is, and the limit of the function of x at x approaches to negative infinitive. Those are the two limits that you need to find so you can determine what is the end behavior. Now I look at my graph. What is happening to the y values as I'm moving towards the right? Positive infinitive. What is happening to the y values as I'm moving to the right? Well, that is approaching this value right here, which is 2/3. And the same thing happens as I move towards the left, okay? Negative infinitive, what is that approaching? Well, that's approaching this y value, which is positive 2/3. So this is by analyzing it graphically. Now, what if it's numerically? Well, if it's numerically, then I need to create a table of values. So here I set up my table, negative 100,000, negative 1,000, negative 100, 0, 100, 1,000, and 10, and 100,000. So again, go to the second table set, change it to ASP mode, and then put the value, negative 100,000. What is the y value? The y value is 0.6666, and it keeps on going, 7. What about a negative 1,000? Well, that is 0.66744. What about a negative 100? And that gives you 0.6745. What about at 0? Well, that is negative 0.5. At 100, 0.6584. At 1,000, that is 0.66589. And a big number like 100,000, and that is 0.66, and it's a whole lot of sixes. Just put a 7, okay? So as you can see here, what is happening as you move to the left, the more you approach to the left, the more that you're going to see that this number is 2/3. And as you move to the right, you're going to see the same thing that is approaching the same number, which is 2/3. So in reality, this is just 2/3 and this is just 2/3. So as you move to the left or to the right, you're supporting that the answer is going to be 2/3, that is approaching the 2/3. Okay, you guys, I hope this video helps you out, make you understand. So